Let's get started. We have a pretty tight schedule. The plan is to build a crypto native game in 1 hour, or we have 2 hours of time, so maybe 2 hours. So let me dive right in. But before we get started, everybody can go to this website, workshop.lattice.xyz, where you can find all the steps for the workshop, like the entire tutorial, all the Git changes, and also download the launcher, download the Git repository, and already run yarn so you're prepared for when we actually get started. And before we actually get started, let me go through a little introduction of Lattice Mud and why we built Lattice Mud and how we came here. And yeah, so basically, Justin already gave a brief introduction into Lattice Mud at the talk, at the keynote, like an hour ago. So Lattice Mud basically allows for autonomous worlds and permissionless extension of these worlds. But the reason we started actually building Lattice Mud was because we ran into very practical problems when we implemented the first version of Ember. Basically, we started extending Ember, adding more features, and at some point we were at the point where every time we added a feature, we introduced 10 bugs, and then we spent most of the time actually fixing those bugs. And that's why we then started thinking about actually which patterns we could use to solve this problem. The first problem we ran into was, like I said, maintainability. And then there were two more problems that we ran into, or two principles that were basically fundamentally missing from the approach that we used to build Lattice with, which was composability and modability. So let me briefly walk you through a very simple example of where we ran into problems. In our old approach, we basically used specific data structures and classes for all the principles and all the things that happened in the game. For example, we had creatures and we had imps in the game. And for both of these, we had a separate class. Then both of these were able to move around the map. So we created a movable class and made creatures and imps extend this movable class. So far, so good. Now, creatures also can take part in combat. So we added the logic and the data needed for combat to the creature object, because at that point, creatures were the only things that take part in combat. But now the point where we run into problems is, at some point we thought, okay, it would be interesting to have a defense tower which can also take part in combat. But now what do? Ideally, we would have some parent class combat which implements the logic and data for combat, and then extend creature and tower from this combat class. But that's obviously not possible with classic hierarchical class-based architectures. So what we had to do is kind of duplicate the logic into the tower class and also have the logic in the creature class, which is not as nice. And then we had chests which had an inventory, but then at some point we also thought of giving inventories to creatures, which again ran into the same problem, had to duplicate the code. So we thought about, okay, how can we solve this problem? We didn't have maintainability, we didn't have composability, we didn't have modability. The first problem we tried to solve was composability. And the solution we found was entity component systems, which some of you might be familiar with if you're coming from a game developer background. We weren't familiar with it at the beginning when we started to implement Ember. Let me briefly give an introduction into entity component systems for those of you who are not familiar with it. It's pretty simple. Entity component systems consist of three things: entities, components, and systems. Entities are nothing more than an ID. It's just a number, essentially. And then the data for the entities is stored in components. Components are only data. They contain no logic, and they can be seen as the capabilities of an entity. And then there's components can be attached to entities to give these entities these capabilities. And how this works is just adding this ID to this component, basically, to say, okay, this entity now has this component. And then there's systems, and systems implement the logic of these entities, and better to say, of these components, because systems act on the components, they don't care about the entities. So how we can solve the problem we had before now is simply by adding a movable and a combat and an inventory component. And then, that was the Lattice launcher. And then we can mix and match these components that we have designed in the first step, movable, combat, and inventory, to create all the entities that we want, basically. The imp only has the movable component, the creature has movable, combat, and inventory, tower is only combat, chest is only inventory. And we can continue adding entities as we like by just adding new components and then mixing and matching these components. And then there are the systems, the movable system, combat system, inventory system, which only care about the components. They don't care about which entity they're acting on. The movement system only acts on the movable component and doesn't care if it's currently moving an entity, creature or an imp. And same with combat, same with inventory. So that solves the first problem of composability. You implement the functionality once in your components and your systems, and then can just mix and match new entity types. Second problem was modability, which is also kind of already addressed by using ECS, but also another way to make it more clear, basically, we came up with separating physics and content, which essentially in the words of ECS just means components and systems are the physics of your game, and then the entities are the content. And after you've designed your physics, like designed your components and systems, then you can just mix and match and create new content without ever touching the code, which makes it much more foolproof, easier to extend, easier to add new functionality. And also, it enables us to, whenever we want to add new functionality, we just add a new component and a new system, and we don't have to necessarily interact with any of the other encapsulated old systems and components. All right, so far for the brief introduction to ECS. If all of this sounded a little bit abstract, it's not a problem. We're going to touch the code in a second, and you'll see how all this works out in actual code. So again, if you haven't already, go to workshop.lattice.xyz. This workshop is intended to be interactive in the sense that you can follow the steps by yourself as well. I'm going to follow the steps here on the stage and explain basically everything that I'm doing and explain all the principles behind. So you can either try it yourself at the same time. Maybe you're not going to be able to keep up the speed if you are not familiar with TypeScript or Solidity. But in any case, you can either listen and watch or also try it yourself. All right, so I will go to this website as well. What you find on this website is basically an overview. It's all the steps for the workshop. You also find the starter kit and the launcher, which we'll need for developing the game, or like seeing what we've developed in the launcher. And then for a later step, after we've implemented the game, we're also gonna integrate it with Persona and like build it and deploy it to an actual chain. And then you'll need a whitelist key generator to get the whitelist key for your game. So let's get started with the first step. I hope you are, all of you who want to follow along have already cloned the workshop, the repo. Also, if you run into any problems, there's a couple of guys from Lattice sitting there. You can just raise your hand and then they will come to your place and answer any questions if you run into problems. All right, couple of problems already. Yeah, and then also in the end, we're gonna have like, hopefully time for a little Q&A session. Okay, so the first step is essentially clone the repo. If you have that, you should be on the main branch. Then go to the step 0 branch, which is basically the starting point for the tutorial. And then whenever you want to skip ahead, like when you are stuck somewhere, want to skip ahead to a different step in the tutorial, you can check out a different branch with the step name. And all the commits in between are also like the in-between steps have their own commits, essentially. Let me just briefly show you the game we're going to implement. So I'm going to switch to step 7, which is the final step. And then what we can do, quickly show you here, like you might not be able to see this actually. What? Make it larger? Yeah. Yeah. So even more? Can you see it? Okay, cool. Yeah, so essentially all I want to show you is if you go to step 7, then you see all the steps before have their own commit and their own basically, you can check out like step 5, the step 5 branch, for example, to skip ahead to step 5. All right, let me show you the game. So when you're on step 7, then you can run, first you have to run yarn, which installs all the dependencies and deploys, compiles the contracts and creates the type chain types. And after we've done that, we can run yarn start to run, so this deployed everything, compiled everything, and then we can run yarn start, and this will start the client and the contract, and then what we can do is open the Lattice launcher. If you're not in here yet, you can just create connect the dev wallet, which just gives you a little burner wallet. You don't have to worry about anything. Just connect your burner wallet, and then once you've started your game using yarn start, then you can see this little banner here on the bottom right. You can click it, and now you joined, like you see your game essentially. Then you can also open the developer console to see all the logs. I'm gonna open this on the side here. And now you can click somewhere. So this is step 7. This is the last step, like the end result we're gonna have. In the end, we're gonna have a couple of entities here. Some of them are imps, they can mine. Some of them are creatures, they can not mine, but they can walk around as well, and they can attack other entities which have the life component as well. And then you have a dungeon hut in the center, which once you, so if I can kill entities as well, and if I destroy my dungeon hut, then the game is lost essentially. So of course this game is not meant to be played by a single player, but multiplayer. Once it's on a real chain, you can just join it with, like all of you can join it essentially and then play against each other. All right, so this as a little demo of what we're gonna build in the end. And now let me go back to step 0 and actually start with the workshop. All right. So first of all, step 0 only is the plain starter kit. So this doesn't include any, like anything specific to the game we're gonna build yet. This only includes the starter kit with some of the libraries that we built from Lattice mud, and some like scaffold code, like the contracts are already connected to the client, their mapping setup. And the only relevant files for now are game.sol on the contract side, and then game.ts on the client side. Let me first briefly show you the contract side, so game.sol. Here we have some component definitions. The starter kit already comes with some predefined components like a code component, here's some more address component, bool component, string component, and so on. Then you have a world, which is deployed separately and then passed to the game just as an address. And then you have the owner, the width, like the size of the game board, essentially the map. You have your components, and you have the method to register the components on this game. And a little utility to remove an entity by just like removing all the components from this entity. And then on the client side, what we also have a world, which is the like client-side copy or synchronized state of the world. And then we set up our contracts. This is also done for us using the library. We get like the contract object, TX executor, which takes care of essentially submitting transactions synchronously so we don't run into any nonce issues. We have the provider signer. Here we get the component addresses, which we then need to create mappings from the contract components to the client-side components. And I'll show you what this means in a second like on the actual game. And then we create our client-side components here, which essentially we mirror we can add any components we want, but also we want to mirror the contract side components to mirror the state of the contract on the client. And then we have a little context object that we can use to pass around like all of these things to the systems. And now I'll show you larger. Yeah, the thing, it gets kind of hard to navigate when it's too large. Right, can you see it like this, or is it very hard to read? A little bit larger? Okay, all right. Yeah, I'll do it like this, and oh yeah, should work. Okay. All right. So let's see how the contract and client component connection actually works in action. So in the game.sol, this is step 1, I think, in the tutorial. If we add, so here it already comes, like in the scaffold, it already comes with a position component. If we now add here, just somewhere where we like create the components, if we add like c.position.set, this is how we set the component values. We just give any entity ID, and then we can set the component value, like this. And now this just sets the position component of entity 0 to coordinate 0, 0. And what I can do now is redeploy my contracts. And then once they're redeployed, I should be able to see in the game client a log where it synced the contract state with the client, essentially. So once I have this game running here, I see the little join local game thing here. I'm going to join the game, and then I should be able to see, oops. Okay, of course, some error. Let's try this again. So components are redeployed, join the local game. And there's some interesting error. All right, let me try a different burner wallet. Also, rebooting always helps. So for those of you following along the tutorial, you can also try this like for yourself. It should work. I don't know why it's currently not working for me. You can try adding like setting the component value in the contract here, and then it should like show the log essentially in the client. Oh yeah, okay, now we have it. I don't know what was wrong. I had to rebuild the contracts. Maybe that was the issue. So essentially now we set the component value on the contract, and now we see here on the client-side logs, we get an event basically through the mapping that the position component locally was set to 0, 0. And then there's also one example system set up on the client already, which is acting on this little component. So let's start actually adding the first real system to the client. We want to be able to display the entities that we've just created on the contract on the client. So what I will do is go to step 2 here, for those of you following along. Also for those of you not coding along, it might make sense to open this page as well, and you'll be able to like follow all the code changes while I do them. It might be easier to follow then. I won't bore you with actually typing this down. I'm just going to copy. This is the position system that we're going to add to the client. But I'll explain everything that's going on here. So we go into the systems folder, and we add a position system. And we put the code here. And so what this does, the systems are also, like all these things are part of the Lattice mud libraries, in this case, the Mobix ECS library. What we have here, first of all, we have a query. We query for all the components on our world that have a position component. What this query returns to us is a set of entities that have this component. And then we can define a system which takes the world and then 2 callback functions. The first callback function is the data function, and every time this data function changes, we will run the second callback function, which is the actual logic we will implement for the system. So in this case, we get also the returned value from the first function will be passed to the second function. Then in the second function, we get the returned value of this query, so in this case, all the entities that have the position component, and we can iterate through them. This is an update query, so every time a position value changes for any of the entities, it will be returned in this query, and this logic will be re-executed, basically. So we can iterate through all the entities, get the component value, the position in this case. This query also returns the entity if the position component was removed from the entity, so we have to check if there actually is a value right now, and if there's no value, we want to remove this game object also from the game itself. And then we get a new object from the object pool, again using the object pool library that's already implemented for us. And then we set the pixel position of this object pool, of this game object, to the position we got from the contract. So this is pretty simple. Then what we have to do is go into game.ts and link the system with the game, basically. And we do this by simply calling the create position system function that we have just created. And now we should be able to see a little game object here. It doesn't have any assets yet, but you see we created an entity on the contract with position 0, 0, and with a couple of lines of code we have now on the client a game object on this position. Let me also open this on the side. All right. This was step one. Now you saw how components work, you saw how entities work, and you saw how systems work already. Let's go to the next step. Right now we don't have any textures here. So what we want to do in this case is actually save the link for the texture on the chain, because then later we can just add new textures and create new entities by simply adding new texture chains, texture strings to the texture component on the chain. A trivial solution, or like a naive solution, would be to just create a texture component and then save the texture for each entity in this component. But then we would have a lot of duplicate strings, even if we have many entities that actually have the same texture. So what we'll do instead is create one texture component and one appearance component. And the texture component, we only save a string once for every texture. And then in the appearance component, we can actually link to this entity with the texture entity, essentially, and then display the stuff client-side. So in this step, we'll only add the components on the contract. I'll start with implementing them on the contract. So first of all, we need a texture component, which is a string component because we want to store strings in it. Texture. And then we also have to import this, of course. Copy this. So we import this, we define it here, and we also define the appearance component, which is an integer component. And that's essentially all we need to do here. But then also we need to, because all these components are separate contracts that are deployed separately using the deploy script. We have a little config file here called lattice.config.ts, where you have to also define the components that you want to have deployed and then pass through the register component function to the actual game contract. So what we do here is as well, we say texture is a string component, and then appearance is a uint component. All right. This is all we have to do here. We will set some component values in the next step, but let me quickly build the contracts, which also rebuilds the type chain, so we have access to the type chain on the client. So I type yarn build. Running all the stuff in the contract pretty expensive. If you run it on Ethereum mainnet, then yes. But if you run it on for example, Optimism and Gnosis chain, then it gets pretty cheap. Yeah, but you couldn't probably afford running this on mainnet, yeah. All right. So we built the new contract, so we have access to the types on the client. And then what we also want to do right now is actually add the textures on the contract. So we added the components, but now let's also add an example texture, an imp texture to the component, to the contract. For now, we just do it in the register components function. So we just define a string, and then we set the texture component to an enum that we also, of course, also have to create first. And now we should be good to go here. I will redeploy the contracts. And then while these are redeploying, integrate this entire thing into the client. So on the client side, again, all we have to do is create the same components here, because we want to sync the state. I'm just going to copy this to prevent having to type it. So we just create the texture and appearance component also on the client. Import these from the components that we get here. And we add them to the components object so that it's part of the context that we pass around. All right, now we have this here. Now we want to create a mapping from the contract component to the client-side component in order to sync the state again. And we should already, we already have the new types because the contract is already rebuilt and type chain is generated. So I can just add it here. And then we have to add also the decoder, which decodes the ABI encoded bytes that we get in the event from the contract on the client. All right. So now we should be good to go. We can confirm in the Lattice launcher. And we see that we, in fact, let's reload this. Let's see. So we do get the appearance, we do get the texture. There's one event without mapping, which is interesting. But we definitely do already get the appearance and the texture events here. Oh, it's because I forgot to, like, this is still the address of the position component, but of course it has to be the address of the appearance component. All right. Now we shouldn't, now we don't have any events without mappings anymore. Okay, so now we get the component values on the client, but now, of course, also we have to add a system to do something with these values. What we want to do here, in this case, is load the assets to the phaser cache and then set the actual asset for the game object here. This is already the next step, so let's move forward here. I'm again going to copy these systems and then explain what's going on here. First of all, the texture system is the one that receives queries for the texture component values and then loads it into the phaser cache. So I'm going to create a new file here, texture system. Paste the code. What we get here is we get all the entities that have the texture component, then iterate through them, get the component value, which in this case is the texture string. If there's none, we just return, we don't do anything. And then we load, this is again a function we get from the library, we load the asset that we have just received into the phaser cache. And then also we update all the entities that have this appearance value right now. In case we updated the texture, we automatically, it gets updated in the client as well. And then I'll add the appearance system as well. What this one is doing is taking the appearance value of the entities and then setting the phaser object value to this appearance, to this texture, which is essentially, we need both systems because this one updates whenever we get a new texture and there are existing entities with this appearance, and this one updates whenever we get a new entity that has an existing texture. So we have this here, and we reload. Oh, we also have to, again, load this in the client, in the game, sorry. So we connect the system here by saying create texture system, and create appearance system. And now we have a little imp there. Oops. Okay. Right now the issue is that we actually gave the texture component the same ID as the texture entity, the same ID as the actual thing. Because we set a position here to 0, which now is the ID of the texture component, of the texture entity. So what we can just do here is change this to 1, and then we shouldn't have this green box here anymore. I'll quickly redeploy the contracts to verify that. Yeah, and now we only have our little entity with the texture that we've just defined on the contract. And now we could just send a transaction to the contract to change this entity, just change this texture, and the texture would update on all the clients as well. So far, so good. Okay, let's move to the next step. Now, I've shown you the game in the beginning, but now let me also show you what the fundamental components are that are powering this game, essentially. So we need some notion of ownership here, because there's multiple players and some entities are owned by some players. So we will add an owned by component. For now, we'll just use the address of the player. Later, we'll integrate the whole thing with persona as well, and then yeah, it's not an address component anymore, but rather a uint ID component. Then some entities should be movable, so we add a movable component, which is just a bool component, meaning it's just a tag for the component. It doesn't contain any real data. It's just whenever an entity has this component, it's movable. Same for miner, meaning an entity can mine some tiles. Then we need a component to show which tiles are mined, so there's a mined component. There's a heart component, which for now we just add to the dungeon heart, and whenever this, like any entity with this component is destroyed, then the player has lost the game. Then there's an attack component, which basically means that any entity that has this component can attack any other entity that has the life component. And the life component is just the life points of the entity. Whenever it's 0, the entity is going to be removed from the game. The attack component contains the strength of the entity, so it's a uint component. And the life component contains the current life and the maximum life, so we can show a life bar later. Yeah, so let's integrate all of these. And these are pretty much all the components we'll need for all the functionality of the game. And since we're already familiar with like how to add components, I'll just quickly add that, all of them at once. So first, this was the client-side components. It's always the same process. If you add new components, you first have to add them to the contract, to the struct, basically to the definition here. We also have to import the ones that are not imported yet. Bool as well. It's cool as well. And the tuple, which contains 2 uints. All right, good to go here. And then we again have to add it to the deployment config so that the components are deployed for us. This is mainly for local development. if later you have your game, you just deploy your components once and then can register them in the contract. All right, so this is all the contract side setup we have to do. And then I'll just briefly rebuild this to get the types. And then what we also have to do again is integrate it into the client. All right. And then the last thing we have to do is add the mappings again between the components on the contract and components on the client. And we should be good to go. So these are all integrated. Shouldn't receive any errors here. Do receive one error. Should be fine. Oh, of course, we also have to reboot the game. I don't think I've done that yet. By reboot the game, I mean redeploy the contracts to the chain. All right, no errors means we have all the settings mapped, all the components set up correctly, and we can go on to the next step, which is adding the first contract system, which is essentially, so on the client, the systems run whenever any data changes. On the contract, the systems don't run whenever any data changes, but rather systems on the contract are more like functions that you call. But they still act only on components, like on the client, and they still can use things like queries and things like checking whether an entity can do something by checking its component. So right now we're going to add the first contract system, the spawn system. And what we want to do with the spawn system is essentially just allow players to spawn somewhere on the map. So I'll just briefly copy this function, which is the spawn function. Just add this here. And what this does is just take any chord and then create a new entity at that chord and give it the texture that we've just defined. I'll also remove this example here and just keep the setting of the texture as just registering the textures here on the registering components. So now every time we call this, we should create a new entity. And then we'll integrate that on the client as well by using the TX executor, which we also get from the library. And we can just add the spawn function here, which I'm adding a function here because then we can add it to the API of the context, and we can actually call it from the command line, the developer console. Right. Don't need this function anymore. Oops. Cool. And this is all we need. Now we just need to, again, rebuild this. Oh, probably shouldn't do that at the same time as this. because redeploying the contracts also builds the files before, and we had to do some magic to make our Forge setup work with Hardhead. So we're adding some symlinks in the meantime. Yes, sure.
What if you introduce a bug in this old function?
Say it again, sorry?
What if you introduce a bug in this old function? How would it not debug? Because you write this specific code,
Mm-hmm.
you write into the contract, and you also wrote a TypeScript code.
Yeah. Yeah.
What if the extreme code is broken?
Yeah, so normally you would not do it like I do it here. I already know it's going to work. What you would do is probably first develop the contract side code, add some Forge tests, for example, and then just test your contract side code first. Forge, yeah, Foundry. It's a testing framework, basically. Yeah. All right, so now we should be able, so we reload this, and now ideally we should be able to call the spawn function. So this is what I said, like we add the context to the console here as well. So we can access all the functions and all the contract methods and everything in the console, in the JavaScript console. So if I call spawn with an entity 1 and add some coordinate, it should hopefully spawn somewhere. Okay, this failed, of course. This is probably what you meant before. This is why you shouldn't just develop everything end to end. Let's see. Oh, it's because I'm just like I'm supposed to add. So the contract expects an entity, I think. Let me check. Oh no, okay. So the contract only expects a chord, and I just gave it an entity and a chord. Yeah, it's because we actually don't want to set the entity ID ourselves, but rather we get a unique entity ID by getting the number of entities that currently exist in the world, and then just set that coordinate of that one. So I just called it the wrong way. No entity ID here, rather just this, and now we get a little imp at this position, which means it worked. Okay. The next step is we don't want players to interact with the game through the console. So the next step is a very quick like input system where we can click somewhere, and then it should spawn there where we click. So basically we add an input system. We again take the libraries that provided by the Phaser middleware package. And then on the client, create a new system, input system. What this one does is so we, from the package, we receive a RxJS stream of click events, basically. And these click events include the pointer at that current position. And then from that pointer, we can get the world coordinates here. So we do some RxJS mapping, piping. We get the world coordinates, then we transform those world coordinates to a pixel coordinate, and then we filter those that are outside of the bounds of the map. And then we console log this just to be able to see if it worked, and then spawn at that coordinate. So now if we connect this system here, we should be able to just click anywhere. This time I don't have to redeploy the contracts because I didn't change anything on the contract. And now if I click somewhere, as you see, it's getting the click event and spawning at that position. So this worked. The next step is to extend the spawn method to actually make it do some useful things, not just spawn a random entity here. And what we want to do here, what we've learned earlier basically, is that now the components that we've just created, we can use them to create our entities, mix and match. Our creature is supposed to be able to attack, have a life, so it can be attacked by other creatures. It's supposed to be movable, it has a position, it's owned by someone, and it has an appearance. The imp has the same components as the creature, but except the attack component and the miner. In addition, it has the miner component because it can't attack, but it can mine tiles. And then the dungeon heart has everything same except the movable component, and in addition, it has the hot component. And then a mine tile is just like a mine tag. It also, oh, it doesn't have a life. This is wrong. It also doesn't have an attack. This is also wrong. It just has mined, position, and appearance. So what we'll do, we want to be able to distinguish the different entities. So what we'll do is load some more textures here. You can load any texture, like with the current game setup, you can load any texture that's a 16 by 16 pixel image, basically. It will be loaded as a phaser sprite. So we'll just load all of these. And we extend our texture enum by the new entities. All right, so we loaded the new textures, and now let's also add, in the same step, extend the spawn method to actually set those components that I just told you about. So we will remove the previous spawn method, create a new spawn method, and what this new spawn method is doing is first of all checking if the current caller already has some owned entities, which means they already spawned. So in that case, we don't want them to allow them to spawn again. Then we create a player entity for this player, set the owned by to the player. This one is not, as you can see, it doesn't have any position components, so it's not actually rendered in the game. This is mostly just to say the player will always have one entity owned by them, even if all the actual entities rendered in the game are killed, because otherwise you could just spawn again when all your entities are dead. And then what we do is we want to have a 3 by 3 area that is first of all mined, and then we put some entities at the different positions. In the center there's going to be a dungeon heart. So this one will have the heart component, the life component. It will have a maximum life of 10 and current life of 10. It also has the attack component, so it can like defend itself. Basically, when someone attacks it, it kind of attacks back, but a very small one. And then the appearance component is set to the heart texture. Then on the diagonal positions, we want to put the creatures, which have the life component, the attack component, movable, and appearance. And then at the vertical positions, we put the imps, which have the other components. And all of those also have position and owned by. So I will rebuild and restart the client, restart the server. Oh. Apparently forgot something. Linting is not ideal. Also, I forgot to mention, we have a little mine utility that we can call to mine, basically to create a new entity with a position and a mine tag and an appearance tag, because this utility we'll also later use for the imps to mine. All right, let's see. Seems like I forgot one of these. Oh, and also I forgot to import something. Where do we need this? This is one of the situations where now I don't have the time to debug this. I don't know why this now popped up here. So I will just like if you get stuck somewhere, you can just jump to the respective commit hash of step 3.4 in this case, and then basically continue from the state. So what we can do is check out step 3 or step 4 and then go back to step 3 basically. Just gonna stash the things I did before. How do I remove all of this? All right, seems like I have to remove these. God damn it. So now we can just jump to step 3.4, which is exactly the one that we were before at, minus the weird error. Now I should be able to run yarn build, hopefully. I'll just clean up my deployment stuff. There might be something going wrong there as well. All right, seems like there was something going on in the previous dist files, so removing those helped. So now we're at the step where we have created the new spawn method. And now we should be able to click somewhere on the map like before, but instead of calling the previous spawn method, which only spawned one entity, now we should be able to spawn like 9 entities. So let's reload this. Oh, actually, I also have to, of course, redeploy the contracts. All right, now if we click somewhere, we should be able to spawn here, and we get all the entities that we had before, that we have just defined in the contract. So now let's add an action method. Let's make our entities actually do something. What we want to have here, like in this first step, is we just want to be able to move entities around, like change the position essentially. So I'll add the action method, which is also kind of like a contract side system, just like the spawn method. And I'll just add this here. And we also want only the owners of an entity to be able to control that entity. And we also only want entities to be able to move to the right, to the tile right next to it, adjacent tile. So let's add some modifiers here. And to compute the distance, we can take the Manhattan Manhattan distance utility that is provided by the starter kit. All right, this is all we want to add here. And then the only thing we have to add on the client is another TX executor, like transaction sending thingy, where we call this function. So we'll just add that here, very simple. This is an entity. And we also add this to the context, so we are able to call it from the console. Yep, that's all. So now, I'm not sure I redeployed those already. Let me do that again. And let me also build this again. And now we should be able to reload the game and call this the action method. First of all, of course, we need to spawn somewhere. And then we need to take some entity. Let's say entity 22 seems to have a live attack movable, so it's one of the creatures. So we can do game.api.action and then move the entity number 22 to a target which is just a coordinate. So in this case, the coordinate of 22 position, current position is 15, 13. So let's move it to one next to it. Let's move it to x is 16. And if we call this, we see this little entity moving there. And we can move it one more, and it moves one more. Pretty easy. Now the next step is to actually add some useful, the next step is first of all to select entities on click and then be able to move them around with your keyboard basically. So for this we need only client side, another component, the selected component, which we then can attach to the entity that we want to move around with. Using our input system. So we'll just create a new entity, a new component here, add it to our components, and then extend the input system to not only spawn somewhere when you click somewhere, but rather we want to, if you're not spawned yet, then we want to spawn. But if you're already spawned, then we want to move the entity that is currently selected to the location that is right next to it. And for this, like this first step is only selecting the entity. So what we need here is, this is a query that checks for entities. So essentially, what this line means is we create a query on the fly and we check for all entities that have the owned by component with value signer.address. So all the entities that are like owned by the current player. And if this is undefined, then it means we didn't spawn yet, we have to spawn. And if it's not undefined, it means we already have spawned, then we get the currently selected entity with this query. We just get the first exists means just give me the first one if it exists. And our query fragments is, we want the one that is selected. And if there's none, then, if there is one, if it's not undefined, then we remove the selected component from the previously selected entity, and then we get the entity at the current position, so the one that has the position component value current position, and is also owned by us, by the current player. And if there is one, then we set the selected component. So here is a couple of things missing from the import. So these are all the things we get from the library, is the queries and the query fragments and removing components, setting components. And then we also have to get the owned, like the components from the context. So we go here, say components owned by, selected, is that all we need? And position. And then also we need the current address from the signer, which is also on the context, so we can do signer, just get the signer from the context, and we should be good to go. This system is already connected in game.ts, so this should be everything we have to do here. And now what we can do is select an entity, and we see this entity is not selected. Like in the console, you see a little log, current entity selected at this position. You can select this entity. It's the position that we just moved to. So this worked. And now in the next step, we want to add key bindings. We want to be able to select an entity and then be able to move around with the arrow keys and with the WASD keys and just take an action to the tile that is in the direction that we're moving to. And for that, we add a little helper function, the action direction, which essentially just calls the action method in the direction that we're currently moving. And this function is then called by the input system later. So action direction, we add it to the internal API, basically. Action direction. We get the directions from the constants, and we import these things from the library. And now we have a function that takes the currently selected, so we give it a direction, and then it gets the currently selected entity. If there's none, it doesn't do anything. If there is one, then it gets the component value, the position component value of the currently selected entity. And then if there's none, we don't do anything. And if there is one, then we get the direction, the new position in the direction of the current position. So directions is just an array, an object which defines all the directions so we can go to. And then we call the action method with the currently selected entity with the new position. And now we can use this in the, we can use this in the input system, adding some new key bindings. So we get this method from the context again. And then we added some new key bindings also from the input library given to us by the phaser engine, phaser middleware. And we add some key bindings for W and up means action direction up, and so on. So whenever we press one of these buttons, it just calls this method with this argument. So now what we should be able to do now is select an entity and then press a button. I just pressed the arrow up key, and it moves the entity around. So it calls the action direction method, and then that one respectively calls the action method, which calls the contract action method, which sets the position component, which emits an event, and then we listen to that on the client, and the phaser client updates. So now we can already control all of our movable entities here on the game. And now this is the most fun step. We're gonna add the actual rules and actions that are possible to take in the game. First of all, we add a utility function, which for the first time actually uses one of the queries from the libraries. I'll explain what it does in a second. So what this utility function does is it gives us the entity that has the given component, but also has the given coordinate. And how we do that is we define a new query query basically, like these 3 lines is defining a new query with our Solidity query system. We define an array with 2 query fragments, and then the first fragment is we want it's a type has value. We want this component, the position component, and we want the value to be the coordinate. So this one is essentially a filter for all the entities that have a position component value of the given coordinate. And then the second fragment is a has type, so only we don't care about the value, we just care about existence of the component that we give here, and we can disregard this, just empty bytes. And then we execute this query using the query library, and we get a list of all entities that match this query. And then if this list is not empty, then we return the entity that we found. If it is empty, then we return false here. And now I have to import this as well. And then let's extend the action function to do the things we want it to do. And I'll explain in a second. So we remove all this. And what we actually want to do is we want to get First of all, we only want to be able to move in a direction that is mined. So we don't want to be able to move on unmined tiles. So first of all, we query for entities that have the mined component, mined tiles, and then at the target position. And then if there is a mined tile, if there's no mined tile at that position, but our current entity has the mined component, miner component, then we mine this tile. This is the utility that we defined earlier. If there is a mined tile already at the position and our current entity has the movable component, and also there's no other entity at this position, like no other entity except for the mined tile. That's why we check for length equals 1. Then we want to set the position of the current entity to that position. And lastly, if none of this was true, meaning there's a mined tile, but it is there is some other entity there, then we check if this other entity that is there has a live component, and if so, we check if our current entity has the attack component, and if so, then we attack the entity. And here it's made such that the defending entity basically attacks first our entity, and then our entity attacks the attacking entity, the defending entity. And for this, we add a little combat utility, which basically just checks the attack value of the current entity, and then checks the life value of the defending entity. If the attack value is larger than the life, then we remove this entity and set the values to 0, and otherwise we set it to, we just decrease the life value. And now we should be good to go here. So now we added all the functionality for the game. This is all the rules we need for the game. And we can rebuild this. And then we can restart the node to redeploy the contracts. And now when we go here, we don't have to change anything on the client now, because all the game logic, all the physics is defined in the contract. And now already, we reload this. We restarted the node, so I have to spawn again somewhere. And now, if I select this entity, the creature entity, and I press arrow up, I can't move there. But if I select the imp entity, which has the miner component, I can press up, and it puts the mine tile there. And then I press up again, and it can move there, because now there is a mine tile. And so with my imp entity, I can now mine, and my creature entity can only move in mine tiles. I can't move anywhere where it's not mined. And then what I can also do with my creature entity is attack my imp entity, and we can verify that it worked here. We received an event that entity 12's life value was set to 2. Previously it was 5. And now if I attack again, select this, attack again, it's going to be removed because it's dead now. So this is essentially all the functionality we have, all the functionality we need in very few lines of code. And now, looking at the time, I'm going to skip actually showing step 6, which is only like polish. It's just adding phaser, like client-side animations and stuff like that, like a life bar and stuff, some particles on attack, some particles when you mine something, a color based on the owner of the entity, and some React UI, basically a flashing model when you lose an entity. And then also, this is the only client contract-side stuff that we'll add here. We would add here is just a little modifier if the current action is actually in the bounds of the map, because previously we only checked that client side, but of course we also have to check that contract side because people can just send transactions manually. And then we will also want to highlight the currently selected entity so you see which one is selected. And that's all the polish. And what I'll do now, looking at the time, is I will just check out the next step, the step 6, and show you how it would look like. So now here you see all the intermediate like polish, client-side polish steps are applied, and didn't reboot my node, which I don't, which I have to because we did actually add one contract change here. So I'm restarting the node. And then in our launcher, we see it looks a little bit nicer. We have a live buzz now. When I select an entity, it gets a little highlight. I can still move around. So none of this, oh, this one is actually disconnected. None of the functionality changed, but we have some nice effects, like some little particle effects when I mine a tile. Some little LUT effects when I attack an entity, and you see the live bar is also changing. And then when I lose an entity, I get this little flash. And then when I lose the game, which is when I like create the destroy the dungeon heart, then I get this little like layover basically. And this is essentially the state that you saw earlier in the demo. I skipped the polishing part, but this would have taken like half an hour. So we just built a game. I mean, we copied some stuff, but we essentially just built a crypto native game in a little bit more than 1 hour. And now Andrew is going to take over and show you how to integrate this game with Persona and then how to deploy it onto real chain.
Okay. So, hello everyone. I'm gonna let's see. Okay. Okay. So, what I'm gonna talk about is so far we've been building this game, right? And you've seen that like it's pretty concise. There's like these nice notions of components and everything, and like once you put in the effort to build this crypto native game, like you have smart contracts running locally, like you have stuff working, like state is like in the smart contracts on chain, right? But it's still hardhead and it's still local. So like the question that we wanna like ask now is like what happens like if you wanna like share the game, right? Like what happens if you wanna make it compatible with like, you know, an actual chain? Like if you wanna make it, like if you wanna like send a link to your game and be like, here, like I built this crypto native game, like it lives on like this whatever chain, like even if it's a test net, but like people can join it. And one idea like in the launcher, I'm gonna disconnect real quick. Like before, like I go in and like make some actual like code changes that I have to make, is this idea that like you have instances deployed. Like the local game available thing is still like, it's an instance of a game, it's just local, it's running on your hardhead node, but like you can make like your game compatible with whatever like, you know, infrastructure is here, and you're able to like, if you do that, like the game is gonna be playable by others essentially, after we do like the deployment. Also, one thing that I remembered, so before, let me see, what is the, you can navigate, so like at this part actually uses, like we need a whitelist key to like, you know, like to be able to join like a game that's deployed. Like you probably have seen like one, like this is just a test deployment that we have here. So like if you need a whitelist key, you can use your event confirmation code to gain one here by like typing in like I have a confirmation code, which is my name without one I, and it's like you can like get this whitelist key. This is like unique to your DEF.CON event confirmation code, or there's like a bunch of free whitelist keys if you want like to like play around with the launcher. Just click here and yeah, just test it out. But like I said, like we'll need one to actually like test our deployment. Okay, so the first thing, so I said like we want to make like our game compatible like to actually like, you know, deploy it. So the first step that we have to kind of, let me go back to, what is it? The first step that we have to take is like integrating the game with Persona. So like Persona is this thing that Justin talked about a little bit during the keynote, and it's essentially like built on the idea that like on Ethereum, like your identity is the address, right? So like ideally, if you join multiple games, you want to take like some, like you want to have some persistence. You want to take your identity with you, but like maybe you don't want to use your like address. So maybe you need some sort of primitive that's like represents ownership, right? And like Persona is that thing. So let's go ahead and like make this, the game that's built so far, like let's make it compatible with Persona. And Persona is like just, like again, like a building block that we've built, like there's a contract, and we should make some changes in order to actually, make it work with this Persona stuff. Okay, so I'm gonna go into, let's see, this is contracts. So the first step that we have to do is like we need to change the address, the owned by like component, right? Like that represents ownership from an address component to a uint component, because Persona is just like basically a number. So I'm gonna go into game.sol, and I'm going to I'm gonna import Persona Mirror. I'm just gonna copy this like for the sake of time. Okay, we're gonna like go change this to a uint component. So so now like component owned by. So like this is the first step. Like then we're gonna actually like add some state to our game. So now instead of like like owner, like we want to have like some reference to Persona Mirror. Like we want to like we need a reference. We need a reference to the Persona contract. Sorry. So like we modify the constructor of the game. Let's see. Let's see. Where is it? Here we like pass in address of Persona Mirror. Yeah, sorry, I didn't mention, like Persona Mirror is basically like the implementation of the Persona contract on a layer 2, which is where the game is played. Persona Mirror. Okay. Let's see. So far, like we've added a reference to the contract, right? So we have a Persona contract. Now, like we're gonna add a function to get the persona. So this is essentially like this is the mapping between like a player's address and the persona. So like if you have like identity that represents you, like you have persona ID number 100. So this like maps like your actual address, like from which you send transactions, to like this like notion of like your persona that represents you. So we're gonna add this function here, real quick. Yeah, you can kind of read through what it does. It basically like it looks up the active persona for message to sender, which is like where you send the transaction from. It checks whether or not you're authorized, and this like again, this is just like the idea is like you authorize a persona to pretend to be you. It's just like it's like it fakes like it acts on your behalf, right? And then you just like return the persona ID from the lookup. So it's pretty simple. And then like we're gonna go into like the spawn function, and essentially like everything is messaged to the sender, right? Because in Ethereum this is like where the origin of the transaction. So we just want to replace that to get persona, right? That's again intuitive. We just want things to be associated with a persona, not with the actual address like that you're connected with or whatever. So I'm gonna go into spawn. I'm gonna change this to get persona. And let's see, we have a few other places to like change this, like get owned by. Keep making this typo. Change this, and what else? Yeah, and we have to yeah, and we change this. So now like everything, like basically when you spawn, when you like create whatever, like, you know, again, this could be any function, but right now it's like spawn, like everything is associated with your persona now. So that was pretty easy. Now I'm gonna go in and quickly change the deploy script. So this is basically what deploys the game, right, like locally. So I'm gonna add a persona mirror address here. So this is required in order to make the game compatible with persona because we changed the constructor. And also now that we're done with contracts, I'm gonna go into the client and I'm gonna make these changes. So again, like pretty easy to follow along. We just go into game.ts. What is this? Oh. I'm gonna change this to a uint component, which is the owned by, right? I'm gonna change this owned by also to a uint component, so just changing everything to make sure it works with persona. Then I'm gonna go into app.tsx. Where is it? Okay. I'm going to change signer.address. This is again the same thing, like associated with a persona. So let's see. So like this now expects a this expects a persona, right? So like I'll change this, and yeah, I need to, like, I'm gonna need to like add it to the context, but for now it's okay. Let's see. Persona ID. So change this to persona. Then go into input system, like signer, like this has to be persona ID now. Okay, so change this to persona ID. Also change this to persona ID. Oh. Okay. And yeah, let's see what else I need to change. Signer.address here. Okay. And yeah, I think there's probably like one other thing that I need to change. Persona ID. Okay. Oh, and so switch everything to persona ID. Okay. So now that like I've changed all the references to like message the sender or the signer to persona ID, now I'm ready to like go into here. I'm gonna restart. I'm going to like redeploy like client and contracts, and it should like the game should just work as as intended, as before, because oh, yeah. Owned by uint component. Thanks. All right, let's start this. What is this? Okay, for the sake of like, okay, what I'm gonna do is I'm gonna like I'm going to check out step 7, and I'm going to like show, okay, I'm gonna like yarn start this, and I'm gonna show, like the point of the earlier like steps was just like, it's like if you look here, like these are the steps that I needed to change. Like again, it's just one component, so you change it from the address component to a UInt component, and like it just works with Persona because everything else just depend, like it only cares about that one mapping function from address from sender to Persona. Okay, so like this this works, and like it's exactly like it's equivalent to how it was before. Okay, so like the last part, like now what I want to show is how we're doing on time. Okay, so what I want to show now is so like we have like this notion of like persona, right? So like we've connected to the launcher with a persona. Like this is the identity, and like we made our game compatible with persona. So like the last step that we want to take is like, let's try to deploy this game that's compatible with the launcher and everything onto a real chain. So to do that, there's a CLI here that's essentially just like some like command line, just like some tooling that we can use to essentially take the code that we've been editing. Like we might change some things, or we might build a game from scratch, and now we want to deploy it through the launcher. So I'm gonna do yarn deploy. And you can follow along because it should just set up. It should open up this like interface kind of thing, like for you to deploy a game. So I'm gonna pick Optimistic Coven, like which is like the optimism running on the Coven testnet. Like we can pick a name for the deployment. And again, like a deployment, just like a deployment of the game, right, of the local game. So I'm gonna call this like D.E.F.CON Workshop 20. Okay, so I'm gonna like add a name for the deployment. I would like to deploy the client, and so basically now like you'll see that the steps taken here are essentially the same as the steps that you were running earlier when you had like the game run on like on chain but locally on a local hardhead instance. So the cool thing here is that like because we picked Optimistic Coven, which is like a real testnet. I mean, it's a real like it's optimism running on a real testnet. Like all the contracts that you were editing, or you could potentially like write from scratch, are being deployed to the real chain. And the option to deploy the game client, where I said yes, of course it failed. What's the problem? Nonce expired. Oh, it's probably because somebody else is deploying. Because it's the same. It's the same account that's deploying. Okay. Well, it's because it's a shared mnemonic, so it's the same account. Yeah. Okay. Let's see. Yeah. Anyways, I was in the middle of saying that like the deployment of the client is like it packages and it builds whatever like you have locally. So like you would just like basically make edits. You could add textures if you wanted to make small mods to the game, and this would build it and deploy it onto the chain. So hopefully this works. It's because like we reuse the mnemonic such that you don't have to pay for gas. It just like deploys it. But it lives in the config file. You configure, you can deploy it from whatever address, and that address is the creator of the contracts, so to speak. And it takes a little while because it's not instant like in Hardhat, like locally, because it's a real chain, so you have to wait for confirmations of transactions. Okay. Let's see. Yeah, and you can see like it's all the different components that are deployed because it's all modular. So it's every transaction is a new contract that gets deployed, and like you'll be able to see it later on like EtherScan or whatever. Let's see. Okay, so nice. Like the contracts get deployed. Now the client is building, so again, that's whatever is in the local repo. So you can be editing it, adding like some text or textures or whatever it is, or just building a game from scratch. And yeah, now it's on the final step of deploying it. This is like the fun part. So yeah, it just packages like the client such that the game is accessible from anywhere. Let's see. Okay, so what happened there is like the script, the command line interface finished, and now we have the option to deploy like this, to finish like adding this game. So basically, what I want to do here is provide some optional descriptions. So like I'm gonna say that this is the result of DEF.CON workshop. You can provide an optional image URL, but I mean, sure, let's do it. Like again, this just the interesting thing here is, and the reason why I'm doing this is because like this lets you configure like your game, right? So like I just want to put this banner there, and I want this to be like metadata that's associated with like the game that's deployed on chain. And this, like, the reason why this says registry is because, again, Justin mentioned this during the keynote, the registry is just a permissionless way where, like, we just store games. This is, like, the ticket there. Okay, so I'm going to click Add to Registry. I'm going to confirm, like, the first step, which is creating an instance. So this is, like, the first, this is the first thing that happens where it's just an instance of this game is registered with some metadata. And then I'm going to add an instance to the channel. So the notion of the channel is, again, it's very permissionless. Like anyone can create a channel. You will see like this DEF.CON here. This is like what like this channel here is. Like we created a DEF.CON channel just for this event. And this transaction here is, you can actually like look at it. It's a transaction on the Coven testnet. So this like adds the game that we just deployed. Like this adds it to the DEF.CON channel. Okay, so now like this, depending on the internet here, like it's going to refresh at some point. Like, oh, there it is. Well, images are not loading because internet. But right here, you will see that this is exactly like the instance that I just deployed, right? So essentially, I took like what the result of all this work is that like we took the client-side code for the game, and we took the smart contracts that were running perfectly fine locally, and we deployed them on a real chain and associated it with this DEF.CON channel. So essentially, like here you will see that the creator is this address that's connected here. So you can imagine that if you want to deploy your own game here, or you want to make some mods, this like you can do it without any kind of like registration or like authorization, right? Like as long as you like have access to the launcher, like you have a persona, right? You can like access this. You can pick whatever like image you want. You can pick whichever chain you want, even like by editing the command line interface. Like the one that we have is just like it's just the one that deploys to Coven. And there's the game here, so I'm going to authorize my burner wallet, which it's like the thing that I use to send transactions. I'm gonna try to join this instance of a game. Yeah, but all of these instances are just starting impersonation. So like you can recall like the impersonation code was the whole like do you have a persona, like is it authorized and stuff. Okay, so it's running now. It's gonna take a little while with internet to like here to register the events. But essentially, what just happened is we deployed, yeah, I'm going to disconnect for the sake of time. We deployed a game that was built completely locally. It was running perfectly fine locally, but we wanted it on a real chain, and we wanted it to be associated with this channel. We wanted to like configure some things about it. And so there it is now. Here, the creator is our address. There's a contract address that we can, you know, like, I don't know if, yeah, I don't, we can open the optimistic Coven, or we can look at the, like on chain, you can find this contract address, you can look it up. The client URL is like also like, you know, deployed at whatever whatever kind of, yeah, URL. Like you can basically like have multiple remixes of this by just like cloning the code, making small change, running the CLI that deploys all of it and adds it to this registry. So yeah, that's I believe that's it. Let's see if that, yeah, I think that's all for our workshop. And should, yes.
The launcher, the Lattice launcher, what exactly does it do that Chrome does not do?
So it's like, so first it's like, is your question like, how is it different? Like if you, I mean, you,
Could it, I mean, I understand why you need this launcher. Could it do all this on Chrome?
yeah, I mean, the idea is that like it's like you do not like it's basically like a cleaner version of Chrome, but the reason why it's easy, the reason why it's like beneficial is because it's deeply integrated with like local environments. So like you can easily have like access to, you know, like that like deep linking between like running CLI to like opening tab, like opening whatever like links you want in the like launcher, right? Like what I did is I ran like some command to deploy stuff. Like it just like, it succeeded, like it deployed a bunch of contracts. And then like the launcher is aware of like the fact that I deployed it. And to do that, like you register, like essentially it's like the launcher, it's a much cleaner way and a more sophisticated way. Like you would have to work very hard in order to put this all into like one web app, because like there's a lot of things that like at the protocol, like this is just a window into a lot of like deployments, right? And it's integrated with tooling such that like you can run it and the launcher knows that like those tools are being run.
It's mostly for the deployment.
Right, but it's also like it's because like it works, like it's chain agnostic. Like basically you can deploy to whatever chain you want, right? But the idea is that it should be a smooth experience from working on the game, like editing the source code, and like adding, like seeing like a local banner, right? Like opening the game and seeing your changes. It should be a smooth experience from there to like actually the deployment process where like your game is on an actual chain. And such that like your like friend or whatever or colleague can like go into the DEF.CON like channel here or whatever like active channel, and they will see the game there versus like, you know, like versus that like you have to specifically like handle like deployment yourself, or you have to give them the URL. Like this is all handled like for you, where you just run the same command and it's deployed like automatically. You don't have to navigate away from the website. Essentially. No, so like they play, like you play it through the launcher. Because like the launcher is actually, like there's no like backend or any kind of state saved. Like it's all interacts with the chain. So if you wanted to, you could build your own thing to interact with the chain. Because like all the games and like all the things deployed like onto the registry or like onto the DEF.CON channel, you can just like use your own CLI, like use like, you know, Forge, Foundry, class, whatever. You send like raw transactions and like deploy yourself. And then you can like, you can see like the state, you can build something yourself in order to interact with it. It's just that like what this allows you to do is to do the whole transition, like I said earlier. And specifically also, this doesn't rely on any kind of front-end code, right? You can, or the contracts. Like you can, it can work with any kind of like like whatever game you come up with, as long as like you make it compatible with Persona, right? Like that was the point of me like integrating initially, was that like if it works with Persona, like you can deploy it here. And so like it's just yeah, it's just like a smooth transition from working on it to deploying. Yeah.
Potentially, I
Yes, correct, correct. So basically, like this, like play instance is like dependent only on the parameter, like this, like it needs to know what the like contract address is, like the metadata, like oh finally the image is loaded, because like you see like all of this stuff, like it all lives on chain. Right. So like it's all like the channel is a collection of instances, and then the instance itself is like some core information and metadata. So an example of core information is like chain ID, where it's deployed, right? Smart contract address. Metadata is like description. This was just like random text. And the URL of like the image, that was like metadata. It's like, it's the token URI function, for instance, right? So like that part, like really, like all of that is accessible. You can all look it up. So if you make your own client that, you can look up all the data, right? If you make it such that you can index all the data, or you build your own like indexer, you use graph or whatever, you can technically do all of that. It's just that like the launcher handles all of the indexing, like it uses like all the stuff in order to make it like show whatever you want to see, essentially. But it's just a window into like that state there. Yeah. Okay. Thank you.